Okay, now disassemble the motor and I'm going to assemble it, put it together and put it to work. Now these are all the components. It's the primary coils looking like this, center tapped at 1200 and 1300 and 1400 turns, and there's 4 of them. And 2 of the 4 coils have secondaries wound on top of them with center taps on 25, 50 and 75 and 100 turns of a little thicker wire. This is 0.75 millimeter wire, and the primary circuit is 0.5 millimeter wires. Okay, I'm gonna put them up and let's see. Now this is the rotor. It is a 6-blade rotor chopped in this fashion and arranged like this, making it self-start. And it's the bearings under there, and there's the measure blade on top, like that. Then there is the capacitor banks, these guys, all wired up in parallel, so I can have an 8 microfarads plus 4.5 microfarads plus 4.5 plus 4.5, adding them up. So I get this diagram where I can have the primary circuits on 1300 turns and then the secondary on 75 turns. And I usually run this on 30 degrees Celsius and the 60 degrees Celsius. The 30 degrees Celsius in this is this side, and the 60 degrees Celsius motor start is on this one. So it starts on 60 degrees, and after 30 seconds it reads 63, and after 1 minute it reads 65, and then after 5 minutes it reads 80 degrees on the hottest part of the motor. So as it can be seen, now by increasing the capacitance, I also can increase the RPM, 2389 divided by 2, because it's double blade. Increasing the capacitance to 29, I get a little bit higher RPM. Increasing it more gives it even higher. Increasing it more gives the highest RPMs, but increasing the capacitance even more, then it starts to reduce. So it's a kind of a curve that that happens, and the goal of this tests, it's a lot of tests, and is to find out where the amperes is more or less stable from start to stop. So in this particular setting, it's seemingly particularly favorable. So I'm going to wire up this one, P1300 secondary S75 turns and 37 microfarads. Okay. And then this is the temperature measure. So my finger is about 28 degrees, and these are the ampere meters, and also measure level this one up. So it's kind of straight. Yeah, almost. So I can screw this one a little bit up. I'll do that later. And then I'm gonna put the video here. Like this. Oh no. Oh. So. Wait a second. Like this, maybe. Oh, come on. It has to be upside down. Oh my sånn. There it is. Like that. Sånn. Okay. Then I start with these coils, and it's very important that the in wire is facing the same direction. So I painted in this marking here on this one and this one, meaning that the north will be out this way and the south will be this way. That will be the same on this one. So that's very important that the in wire goes to the out wire of the next. These are all wired up in series. These are the 230 volts terminals that goes into the wall. So I'm going to begin with the in wire. The in goes to the face. And then around this one. Now let's have them maybe this way. So in and then out, and this is 1300 out to in on this one. And I have a little sugar cube. 1300 out to in. In, like that. And then 1300 out. Where this is 1300 out to in. This one, and the label is facing this way. Label is facing that way. Okay. Out to in. This one. And this one also there. And this one. And goes in. There. Out, in. No, wait a second. In, out. In, out. In, yeah, and out. 1300. 1300. This one. Goes to out to in, and this one in. This has taken a long time to finalize the project, but I got and it will never be done, but no matter. Skal vi se. 1300 out to in, and then 1300 out to the face. 1300 to the face. Okay. So. And then I'm gonna have the ampere meter to measure it. This one goes in series with the circuit, so I'll take it somewhere. Doesn't do too much hassle. So I can take it in maybe back here somewhere. Let's put it in into here, into this, and into this. So you can put that there. Now I'm going to have the capacitors, and what I gotta do every time is to measure the capacitors, and I have this additional meter that I measure here, and it's I don't know if it's visible, but it's already set to 37 microfarads. If I remove one of them, it's going to be less, 33. So I'll put this one back in, and then this capacitor is going to capacitate this coil, primary on this one. So that means I gotta go into the out on this and the in on this side. So I have this, and the out is in this guy. So I'm gonna have this. Out there, one side of the capacitor bank there. This is the out, and I need the in. This is the in. This is the in. This is the in. Yeah, this is the in, and this is continuing over there. Yeah. Okay. So the other guy goes in here. In here, in, and into the bank. So now this coil is, the primary is capacitated the same on this one. In, or yeah, in this one, I gotta have one wire into this, and another wire into the out, and that is this guy, and that's open there already. I can put this into there, like that. Now it's capacitated. Now it's the secondary circuit, and I gotta have that on 75, center tap 75, and this is the in wire. The in wire on this has to go to 75 on this one. Where is that? 50, 25, 75, there it is. Okay. I'm gonna have a little splice. Splice. Oh. So, to 75. Sånn. Into this one. There. And then the in wire from this one to 75 on this one. yeah, I'm not gonna go through through an ampere meter. I can just use that as a splice. So in, and then through the meter. Through the meter's on. There. In to 75 out. 75 there. Out. Ja, der har vi en sånn, ikke sant? Så out sånn. And then a little splice on there like that. Sånn. This guy goes into this. So now this is supposed to be wired up. There's only one way to find out. And yeah. I was just about to check that yeah. There's no short circuits because these are open terminals and not insulated. The ends are not insulated, so if they collide, it can be a little problem. So just make sure nothing is shorted too bad. Like this, like that. So it looks like a mess, but aesthetics can be dealt with later. Now it's supposed to be okay, and just to make sure I can put voltage on it and see if I get any readings and if it explodes, what it does. See, no explosion. I get yeah. I'll turn it on. The meters are 0.75. It's 0.78 on the primary side, 0.78, and what I had last time was 0.79, so it's not very off, it's pretty much the same. And on the secondary side it produces 7 amperes, 7.3 amperes. And actually last time I had 6 amperes, but that was when that one was 42 degrees, and now I can measure. It's off now, and I can measure 29 degrees, so when I measure 40 degrees on this one, maybe. So I'm gonna attach the rotor and see if we got any rotation. So it's off right now. I'm gonna put this into place and maybe level it up like this. Yeah. Check that it's like this, you know. So I'm gonna lift it up a little bit here, drive down this one, and it's stable. And this top, oh my god, it's way out of whack. Yeah, it's good for now. It's almost. I usually have screws here that I bolt it, but for now, let's try. Yeah. Then I have this laser meter that I actually measure the RPM, but when I hold this by hand it's not going to be very steady at all. So after 5 minutes it's supposed to be 2566 divided by 2, drawing this ampere. So it's 2.3, that's 1400 RPMs. 2.5, 80. Yeah, it's better now. It's giving it's a better result now than it used to have. But anyways, it's yeah. 2.7. Okay. Yeah. Yeah, if I do like this, it's all gonna jitter up. But that's like a proof of concept, and it's built. It's built on the motor by Nikola Tesla from 1894. It's a little modification of it with the secondaries and all that. So yeah, now it runs on 7 or 6.9 amperes on the secondary and 0.8. 0.8. It's a little lower. It's 6.6 and yeah, it's a little bit off, but it's not that much. And then you can actually do this temperature thing while it's running. It's insulated wire, so it doesn't 59 Celsius degrees. So it's working. Yeah, it's working. Yeah. The magnets aren't attached properly, so they drift a little bit out of position, but it's the way. Spent a long time on it, and I learned a lot of stuff from it. Okay. Now once this one stops, I'm gonna end the video, and that's gonna be that for now. Okay. Yep. 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 So it can't lift very much, it's not very strong. It can't lift very much. I can stop it very easily with my hand, There isn't much torque in it or lifting capacity, but I gotta work on it.